We are Team Hot Stuff, made up of Caden Goranson, Ryan Mach, Andrew Schaub, Riley Schroeder, and Ben Napier, and we made a desktop injection molder for our 301 project.
As plastic pollution is destroying the environment, the use of recycled plastics is increasing worldwide. So our problem was to design and build an injection molding machine capable of utilizing recycled plastics of various materials and different concentrations of recycled plastics and new plastics to try and reduce the pollution and the amount of wasted plastics that go into our environment every day.
Our objectives for the injection molder were to make an effective and reusable design while minimizing the amount of code required, wiring, total machining time, and minimize the total cycle time. We wanted to make it easy to assemble so we could take it apart and move it to other locations, and then we wanted to be able to melt plastic without burning or boiling it and creating an inadequate part.
Some of the main design constraints that we had to be mindful of during the design of our project was we had to stay under the budget of $230 that was imposed by the school. We had to finish the project in one semester of school, or about 360 hours of possible work time. It had to be safe to operate, able to plug into a wall outlet. We had to be able to pick it up. And it also had to be able to take pellets that were made by the shredder teams in our class, so about a tenth of an inch size of PLA pellets. In this video, we are using our PID controller to set our set temperature to 180 degrees, and then once it gets to 180 degrees, it overshoots about 15 to 20 degrees on average, so it'll get to 200, and once it reaches the 200, it'll come back down, and then we'll set it back up to 205, and then it'll overshoot to about 220, which is our injection temperature, and once it reaches the 220, then we inject.
So here we're using the bottle jack to press our barrel and mold assembly up into the plunger, and this forces our molten plastic down into the mold to create a usable part. So in this video, we are removing our mold from the injection molding machine. So you're using a welding glove and these clamps to hold on to it because it's really hot, and so we're just pushing it down and removing it.
Here we're using an Allen key to unbolt the two plates on the bottom of the mold that are used to clamp it together and connect to the jack. Once they're off, we are going to be able to remove the C-clamps and open the entire mold.
As you can see here, we are removing the C-clamps from the mold so that we can take it apart, and we're using a screwdriver to pull it apart. And right there is our finished product. It comes out really easily because we use mold release on the mold.
Here we heat up the plastic to remove the barrel from the plunger, and it's self-cleaning, as you can see.
Our final prototype was different from our original design we created. Our original design was based on a lever-actuated arm controlled by human power with a sheet metal body. We ended up changing to a square-tubed steel design with a bottle jack. Our final design had no possible automation, unlike our goal in the original design.
For a future design, we would like to modify our mold so that we can take it apart faster, removing the use of C-clamps and all of the screws that we had and simplifying it to just a couple bolts. We would also like to add cooling channels into our mold so that we can decrease the cycle time between injections. We also want to make it so that it could do multiple types of plastic, such as PETG as well.